Hey everyone, thank you for joining today. I'm very excited to start this presentation of the Datadog State of Serverless Report for 2021. We're gonna get kicked off now. And for folks who aren't familiar with this is a report that we do every year about the state of the serverless industry. We ran one last year, and this year I'm excited to present our newest research. And along with me is Chris Munns from AWS. Before we get into it, so Datadog is a monitoring and security platform for cloud applications and a place where you can monitor the end-to-end visibility of all of your serverless applications. So I'm Stephen. I'm a product manager at Datadog. I've been here a little bit over 2 years working on all things serverless. And Chris, I'll let him introduce himself.
Yeah, hi everyone. My name is Chris Munns. I currently lead developer advocacy for serverless at AWS. I've been at AWS now together for about 9 years, been in the space of serverless for the last 4.5.
Awesome. So before we dive in, I think it'd be great to talk about some of the methodology for the report. So what exactly did we look at in this? Also, this is a live QA session as well. So Chris and I will go through all of our findings one by one and talk about them. And then we'll also send out a recording of this to everyone who's in the panel right now, as well as link to the report. And then if you have questions, feel free to put them in the Zoom chat, and Chris and I will address them as we go and also at the end. So for this report, we looked at all Datadog customers who are using serverless. And for some of these particular customers, or for some of the particular facts, we looked at if they're using Lambda, we wanted to see at least 5 functions that they're using. Or if we're looking at particular cloud providers, we looked at do they have at least 5 VMs that they're running? Or how much are they using the cloud? We looked at their entire footprint of VMs, containers, serverless functions. And so this is a representation of Datadog's customer base, which does generally represent very forward-thinking organizations embracing the cloud early on. But this is a very large slice of a very large market. And we think our findings are fairly respective of how developers are using serverless today. We're excited to share that with you.
We could be honest, David. We could say that it's what cool people are doing.
Yeah. Exactly. Everyone who knows is using serverless is in this report.
This is the report on cool people.
Yeah. So, as we get into it, so we saw when we looked at just how often are people using Lambda functions, we saw they're being used way more, 3.5 times more than they were 2 years ago. But I think, we first need to get into what is serverless, Chris?
Yeah, so backing up and talking about what we're going to talk about here today, from the AWS side of things, obviously when we talk about serverless, we talk about what it means from basically a benefits and capabilities perspective. So we're talking about technologies that remove a lot of the operational burden that you would typically have, that get you away from upfront thinking about running servers. So what does it mean to run servers? It means thinking about operating systems, patching operating systems, having to deal with the kind of individual instances that you might have in the past, or even container orchestration. And so for us, serverless gets rid of those things, includes benefits like automatic scale up and scale down, ideally paying for nothing when you're not using anything, built-in high availability and fault tolerance. And so that's kind of how we categorize serverless services at AWS. Now, the center of that for us is obviously Lambda. And so Lambda is a compute offering that we first announced back in November 2014. So in cloud years, that's like 100 years ago, right? Like a lot has come, a lot has changed. I was gonna say in dog years, but maybe that would be too on the nose here. But over the last really 6-7 years, as charts like the one here will show you, Lambda has grown to become a very commonly used compute offering inside of many of our customers' architectures. And what Lambda is itself is, the simplest way to think of it is the way that you can run code without having to run any infrastructure whatsoever. It responds to events. Events today can come from over 200 different services and places that can connect to Lambda, either via direct interaction or via services like SNS, Amazon SNS or Amazon EventBridge. Again, it's meant to be a very simple compute offering in terms of knobs and levers, but one that we see customers doing things at great, incredible scale.
And the world is bigger than Lambda, right? Like I hear about all these serverless container platforms as well. And so there's recently an announcement around App Runner and looking at other parts of the market. There's Cloud Run and stuff. And how do those fit in as well to serverless? Why are they serverless?
Yeah, so it's again, some of it's in the eye of the beholder of what is and what isn't serverless. If we talk about the broad scope of the compute spectrum that's out there, from the AWS side, we have everything from physical hardware that you can access, things like our Nitro platform, up through instances in EC2, the various container offerings that we have, such as ECS and EKS and Fargate, and then all the way up through functions as a service, which is what Lambda is. So we typically consider Fargate to be a serverless offering. You don't deal with the cluster management, you don't deal really with the operating systems. And so we recently announced, I guess it was just last week, a service called AWS App Runner. And it's a pretty cool service. So basically what it does is a very high level orchestration on top of, in this case, it's Fargate tasks behind the scenes, or containers running inside of Fargate. And it helps you with things like load balancing and deployment, scaling, operational aspects. And so there's a lot that it does that layers on top of that as a serverless stack. We look across the industry at what other cloud providers are doing, open source projects that exist out there. Really what we're seeing is just what we've seen with cloud since 2009, 2010, or earlier maybe. This idea that companies want to reduce the operations that they have. They want to reduce the kind of undifferentiated heavy lifting that they have. And so the more that we can peel away those layers of responsibility while still allowing companies to meet their performance goals, their security goals, their various organizational needs for the business and stuff, that's where people are finding success in these types of tools.
So you're saying I can write code and then hand you the pager so you can go fix things when something goes wrong with a server on a rack in a data center somewhere?
To a degree, right? So I mean, even with technologies like Lambda, we talk at AWS about this shared responsibility model, typically from a security perspective. I would say even from an operations perspective, there's kind of this balancing point of, okay, we take care of all the duties below this point, and then above this magical demarcation line that we have, there are still things that you would have to own, such as writing, creating good, well-coded applications, securing those applications at the code level. And so those are still those things that you still have to perform certain tasks on, that you still have to essentially have that ownership for. But again, below that line is an entire tech stack that's incredibly powerful.
Yeah, that makes a lot of sense. And then before we move on, so it seems like if Lambda functions are being invoked more people are also probably using Lambda. And is it only companies that are cloud native that are using it?
Yeah, so Lambda is a fairly interesting service in that when we look across the companies that are adopting it and the types of use cases, it's really, really varied. We have companies like Lego that build, using serverless technologies into their e-commerce stack. We also have organizations like FINRA in the United States, the financial regulatory company that is processing stock trades and looking for fraud or bad transactions, all the way up through hot startups, financial sector customers, healthcare customers. We actually had in this past year quite a number of states and countries and localities that built either COVID tracking apps or vaccine registration apps using a serverless stack. So it's been really interesting to see how it kind of grows and expands. Now, when we talk about this term cloud native, it's gotten a little overloaded in the last couple of years. I would say typically referring to things like Kubernetes and the whole world that exists inside of the ecosystem for, say, like the CNCF. that definitely represents a segment of things. But I would say, again, we see all sorts of organizations looking at using Lambda. I think to this chart here, there are customers that we have that have Lambda functions that are tied to infrastructure things, notifications of a change or responding to events or security or things like that. Those may get accessed very infrequently. But then we also have customers that are building, APIs that talk to mobile front ends or devices, or internal microservices. And so there's a lot of varied use. There's things at the high throughput, high concurrency side of things, all the way down through the actually this function only runs if something goes boom, and that we hope that it never goes boom. But what's great is that you don't have a permanent compute resource sitting around costing you money for those things that you may very infrequently access or run.
Yeah, absolutely. So it sounds like it's a little bit of everyone.
Definitely.
So moving on to our second finding, we saw very fast adoption of function as a service products across every cloud provider. And so we saw this specifically as at least 1 in 5 organizations is using a function as a service product in each cloud. And so with AWS, this is Lambda. For Azure, Azure Functions, and Google Cloud, this is Google Cloud Functions. Mm-hmm. And so it seems like from this data that there's a huge demand for serverless. And this is only looking at the slice of the market for function as a service products. From your purview, though, what other serverless technologies are people flocking to besides the ones we talked about earlier?
Yeah, and again, I think it comes a little bit to how you think about defining and using the word serverless. So functions as a service is definitely one aspect of it. For us at AWS, it includes a lot of things. It includes storage services like Amazon S3 or Simple Storage Service, which is one of our original services here at AWS, going back now over 15 years. It's services like Amazon SNS, Simple Notification Service, and Amazon SQS, Simple Queue Service. These are products that customers are using between microservices. They glue things together. They allow you to pass messages back and forth or queue up events. Again, the simplicity aspect of not having to manage resources becomes incredibly key. For us at AWS, you're seeing us embed this concept of a function that responds to an event all over the place. And I know we're going to talk a little bit more about the edge here later, so I won't get too in front of that. But we recently launched a new functions capability in CloudFront. We also recently announced a different way that S3 can integrate with Lambda. And so, there's a bunch of places where this function-based concept just makes sense. And I think what we're seeing across the industry is, for people who are very dedicated to some of these other cloud providers, they're starting to wake up to the capabilities of those products, how they can be used. And so, in my mind, just seeing the growth of FaaS and functions as a service is just kind of the sign towards what we're seeing the industry shift towards.
Yeah, and I saw we got a question about, what about the data layer here for serverless data storage, probably around DynamoDB. I know from our perspective, we see a lot of customers using GraphQL, and specifically like the AWS managed flavor of GraphQL called AppSync. Mm-hmm. So curious what kind of trends you're seeing on the data storage side.
Yeah, so there's a bunch of aspects to this to kind of peel back. On one side of things, we talked about that Lambda is an ephemeral product, so storage kind of comes and goes with it. That said, last year we announced integration with Amazon Elastic File Service, so the ability for you to create these storage volumes, effectively like NFS volumes, as it were, shared storage that can attach to Lambda functions so that it can be a persistent storage that exists with those functions. So I think there's storage like that. There's storage like S3. And then as you're describing, there's kind of the storage that we see with databases and how data is stored throughout applications. So, services like AppSync, which is a managed GraphQL offering, which you touched upon. A lot of customers put things like DynamoDB behind that. They also put Lambda behind that. They also put other data storage or databases behind that. And so in a lot of instances, though, I would say the ephemeral nature of Lambda just means that you're not storing the data in your FaaS. You're putting it in one of these kind of purposely built products that exist at the other side of those.
Mm-hmm. Yeah, that makes a lot of sense. That definitely reflects what we hear. Now, moving on to looking at the duration of Lambda functions. This is always interesting, and we reported a little bit on this last year, and we went back and crunched the numbers. We saw some interesting new trends here, where the median Lambda function invocation is actually decreasing, while there's still a long tail of long Lambda functions. And so, it seems like this might be developers adopting best practices where you have smaller but more stateless functions that aren't blocking as much on synchronously requesting another Lambda function. But does this match your hypothesis? Like, how are you interpreting this data?
Yeah, it's interesting, and I know we discussed this one a little bit the other day, kind of going back and forth. Now, one of the best things about Lambda that I always like to talk about is, from our customers' perspective, is you wake up some days and Lambda is just better. It's faster, it has new capabilities. It's been secured against various issues that might pop up with the runtimes. And that's stuff that, as a managed offering, we just do for you. So customers are regularly seeing the benefits of us shaving milliseconds off of milliseconds at some point of the stack that Lambda runs in. Do I think that's responsible for decreasing the invocation duration by half? Probably not. Although for some customers, they definitely see those benefits in the further performance ranges. I think what you said here is totally right. Like, we've been, so again, backing up, I lead developer advocacy for serverless. I have a team of people around the globe who work with me. AWS has a very large, sales force and technical field as well. And so we've really been pushing the, optimization best practices angle for the last couple of years. And I think what we have now are a number of kind of really proven at scale best practices that most of our customers are starting to take on. And I think that's where a big part of this comes from, is customers are just being smarter about how they create their functions, what their functions do, where they are, initializing resources, say at a cold start, pre-handler versus in the actual function invocation. And so I'm going to bet that this comes down to better, more informed, smarter customers versus any sort of other big technological change that we've made on our side.
Yeah, absolutely. It seems like it could be a little bit of everything here. Mm-hmm. But we definitely have heard about different Lambda teams optimizing runtimes, and but developers are also just getting better at running things on serverless. Yeah. I saw we got a question about Lambda extensions. We'll actually get to that later. Very topical question.
Yes, definitely.
Now moving on to step functions. Step functions are super interesting. So the way I kind of see them is it's a way to orchestrate a more complex workflow. You can define a series of steps that say, if I need to download some data, process it, and then upload it to an S3 bucket, I can define some logic that says each of those is maybe a Lambda function or runs an ECS, depending on which technology is most suitable for running it. And then I could say, if this step fails, so if I'm unable to download my data, retry that step until it passes, and then go to the next one. And then I can do sort of branching logic that says, if this does work, or if this doesn't work, then do this other thing. So I talk to a lot of customers using step functions for all sorts of things. I'm curious what you see for step functions, especially around, it seems intuitive to use this for a background data processing job. And so curious what use cases you see there, but then also on more real-time web applications.
Mm-hmm. Yeah. So for those who are not familiar with AWS step functions, again, this is a product that's been around now for a couple of years for us. And really, you could think of this as a managed serverless orchestration product, with the idea being that it tries to take away a lot of the code that you would have to write for integrating services, for things like you just mentioned, Stephen, failure and retry, parallelization, decision tree following, which is really common code that people would end up writing themselves. And so it takes this as a managed service. It manages your workflow in what's called a state machine, which tracks the state of that workflow. While it's true that step functions is used very heavily with serverless applications with Lambda, it also integrates with, I think, almost about 20 other services now. So you can integrate it with ECS or AWS Batch or SQS and SNS or DynamoDB. And so there's a lot of places where you can remove code and just use step functions, which is really cool. Now, it's actually one of my favorite services that I find that people, again, don't see the full capability of it. And it's for some of the reasons that you just hinted at, which is the varied use cases. We have customers using step functions for everything from, say, a checkout workflow to ETL or machine learning or data processing. And we actually have a number of integrations with some of the data services here at AWS that help power all of that. And so what's really fascinating is sometimes when a customer says, or someone comes to you and says, hey, I want to talk to you about step functions. You're like, oh, where are we going to land with this one? And so I think that's where you see some of the kind of really big gaps here between the execution time in this, is that it is some of these really long running workflows. And then you have some that are really, really quick. And so this was about 2 years ago, we came out with a capability called Express Workflows, which is meant for sub 5-minute workflows. And where we actually see this being used quite a lot is in that like near real-time synchronous capability. So you can actually put that behind API Gateway and be able to talk directly from Amazon API Gateway to step functions without having to go to a compute layer. And so what this allows you to do is to complete a whole workflow of tasks behind the scenes, and again, reply back to your client later on. And so that's a really exciting capability, because again, what it means is that the actual code that you're writing ends up being largely just business logic. You're not doing that failure handling. You're not doing, again, the decision tree aspects that you might need to. And so we're starting to see customers build more robust APIs actually with step functions powering that API's logic. And so that's probably the big part of this 0 to 1 minute column here, which are these very, very fast executions that customers are putting again into like near real-time workflows. And then again, some of them are these asynchronous ones where, again, things like a checkout flow, things like order flows, which are a little bit different in this case from checkout flow, but similar concept. But yeah, it's fascinating the range of things that you can do with such a kind of raw tool such as step functions. But then again, the work that you're not doing and writing all of this custom code is really key.
Yeah, and my favorite step function fact is always that they can run for up to a year. And I think we see that represented in this 24 hours plus bucket. But I'm curious from your angle. I know you can't share, but just what are these year-long step functions doing?
It's a good question.
Hopefully not a checkout flow.
Yeah. One thing you could do with step functions is actually have like manual or human intervention workflows. So you do have the ability for a callback model such that you could basically just say, hey, wait until I hear back on this thing. And this thing could be some sort of really long process. It could be a manufacturing process. It could be you could build a workflow around all sorts of things that might have a long duration of time that exists inside of them. And again, where step functions can maintain that state for you. And that's one of those key things. I was going to say, I would love to see how far out your long tail is to compare it to what we have. But yeah, it's definitely something that we see happen.
Yeah, it'd be interesting to compare notes on this. So moving on, just in the interest of time, I saw we got a question about step functions that we'll try to address at the end.
Yeah.
But you mentioned edge computing. We have to give the people what they want. We saw this very cool stat that when we dug into it, 25% of CloudFront users are adopting edge computing. And so for this, we looked at Lambda edge usage. CloudFront functions just came out as well. That's another answer to the edge computing market. And I find this interesting. I used to work on a different edge compute product actually before I worked at Datadog. And what I always thought was interesting was seeing the trend in edge compute go from let's modify requests and headers and files sort of on our way to our origin application to like, how can we actually move our applications to the edge? And so curious, like what are some of the interesting use cases that you see around edge compute? But then the question that's always interesting here is where is this going to go?
Yeah, people are always saying it's the early days for edge computing, but I feel like maybe we've been saying that for a couple of years now. And then slightly behind the scenes, there's been growth in products like Lambda Edge, and then we recently did announce a new product called CloudFront Functions, which has a slightly different performance profile, slightly different capabilities, and so the options out there really span a whole number of use cases. I think where we see Lambda at the edge today, as you mentioned, it's a lot of interactive workflows, so mobile and web, but it's also IoT. And IoT in the sense of everything from sensors that exist in our home to sensors that exist out in planes, trains, and automobiles, as it were. And really the idea here is that, often these devices that you have, while quite powerful, might be difficult to update or difficult to get new capabilities and features into, or might just be constrained in power. And so by moving some of that compute tier to the edge, you can still have the performance that you need of, as close to, again, real time maybe not being it, but as minimized of a latency as possible, to meet the demands of what that device needs to do. And so we just continue to see this area expand and expand. Again, in the mobile and web side, I think what it's leading to is much more responsive web applications, much more responsive mobile applications. And as our lives continue to become more and more centered around these, again, devices that we wear and we hold, that performance becomes really key to the success of many of our customers' applications. So, again, the line that it's like, oh, edge is growing, it's the next thing, it's the next thing. I think we're really seeing the benefits of edge here. I think, having 1 in 4 CloudFront customers using the product based on your data here is a huge thing, to the testament of just, how widely adopted these concepts are now.
Yeah, and what I always remember hearing here was that writing different templating languages to describe behavior of a CDN is just always can get tedious. You start with one rule to modify a header so that your customers from France or Japan see a localized version of a page, but then it sprawls into something huge that's difficult to manage. And that's where handling this dynamically with an actual compute layer can be easier to manage, and also easier to store it, to test and store in version control.
Mm-hmm.
And then, just adding on here, we see these use cases being for very small things. People, if you're running code at the edge, it makes sense for it to execute as quickly as possible. So we see like a huge amount of Lambda at edge functions running in this small bucket here, where they're executing extremely quickly. So in 20 milliseconds or less.
Yeah, and I would say actually real quick back on that one, with CloudFront Functions that we just launched, the maximum execution time is actually less than a millisecond, or it's basically 1 millisecond or less, I guess is what I would say. So even from this first chart, we're talking about the even higher or even more, lower latency type customer use cases, of which there are a lot of. Many of those aren't just web and mobile related, but again, are things where, hey, I need this sensor to be able to process this number against something else really, really fast. So these workloads, much like we saw with Lambda, keep getting better, keep getting faster. Customers keep needing and requiring lower latency. And so CloudFront Functions itself is built for that even lower latency requirement that customers have.
Mm-hmm. Yeah. So I spoiled the next fact here, but this one's very interesting. I remember a while ago, I forget exactly when it came out, but provision concurrency has been here for a while. And I think what was super interesting to developers here was it meant that cold starts went away. Cold starts are, generally a thing of the past, but with provision concurrency, it was a way to guarantee that there were no surprises. And when we looked at the data for how people are using this, like our customers come to us asking, how do I know that I'm using the right amount of provision concurrency, or should I use it? When we looked across all of our customer base here, we saw that many of them actually were overspending or over allocating on provision concurrency. So for anyone who's not aware, I guess, could you explain what provision concurrency is and maybe why this is happening?
Yeah. So we'll step back a little bit to explain kind of one of the fundamental concepts of Lambda as a compute service. So Lambda operates in response to events, API calls, objects being put in S3, messages being sent to SNS or SQS as examples. Those events then go and hit the Lambda invoke API, which is like a control plane service that we run. And then that API has to spin up compute resources in response to those events, pull in your code, and then invoke and execute your code with that event. Now, everything between that time where we get the request and then we can begin running your code is considered a cold start, at least for the initial time per an environment. And so historically, that cold start was probably the one, a very misunderstood concept. Two, was the place where customers would see performance pains. Now, I've been saying on stages and in tech talks like this and in social media and other places, probably since we first released this stat back in, I guess, 2017, is that this concept of a cold start and cold starts in general impacted less than 0.25% of all invokes of what we would track as to be a production workload. And its production workload meant something that had a regular amount of traffic to it over an extended period of time. And then again, after that environment has processed that request, it sticks around for a period of time where it's considered warm and then can process other requests after that. And then after a while, if traffic goes away or load reduces, those resources become idle and we essentially reclaim them back into our pool of resources. So cold start, warm start, and so forth. Now, cold starts were again a real thing. Customers have certain latency needs in their applications. They have certain speed and performance that they are looking to meet. And so historically, this was one of the kind of rough edges to functions as a service offerings. Now, I remember also many years ago, Jeremy Daly, who's well known in our community and kind of family at Serverless, and he actually works now for Serverless, the company that makes the Serverless framework. Him and I talking at a meetup in Boston, and the outcome being this incredible blog post that talked about how to warm your Lambda functions. And it was basically, run a cron job or, a scheduled Lambda function that would then go and invoke other Lambda functions to keep them warm. And so we've had customers doing that for a long time, but we really wanted to come up with a better solution. And so we launched provision concurrency back in December 2019, which feels like forever ago for sure, but just, again, really 18 months and change ago, I guess now. And so what provision concurrency does, as the name might sound, is it pre-warms those environments for you behind the scenes and can keep them warm. And so for customers that have really low latency requirements, this is a great solution. Now, the challenge is that many companies don't have low latency requirements. They also don't necessarily understand their own traffic patterns. And so I think this is what leads to this stat of that, quite a number of customers are over provisioning this. We're trying to put better tools in place to help make it easier for customers to understand this. We're also trying to provide education so that customers can understand this because we want to see, customers right size essentially provision concurrency for what they need. And so this is actually where y'all come in, right? Because you've got data that customers can look at to understand, what their consumption is of these, of functions that are configured like this, and be able to, over time go and adjust that. But I would say in general, customers should be thinking about provision concurrency largely just for interactive workloads. So web, mobile, IoT, places where the response time really, really matters. Less so for asynchronous workloads or stream processing. So that means things like processing queues or objects out of S3 or objects out of Kinesis or DynamoDB streams. That is where provision concurrency probably doesn't benefit you a ton unless you really, really, really have a exposed to user near real-time experience that you're trying to solve for.
Yeah, that definitely reflects how what we recommend to customers as well, also a thing to kind of test out and tweak as you go. So you can set some provision concurrency and then see how many requests are sort of spilling over beyond that, and then adjust accordingly, or configured on a schedule. So you know when your traffic patterns are going to hit. And so, you know, at 8 a.m. every morning when people are coming to the office or opening their phones, you might have provision concurrency set up.
Yeah.
So speaking of Jeremy Daly, speaking of serverless framework,
yeah.
We took a look at what are the deployment frameworks, the infrastructure as code tools that developers are using for their serverless applications today. And you know, we love all of them equally. They are all have a lot of very interesting, very compelling features. And what we saw was a ton of developers using the serverless framework. And so love this tool. It's driven by this open source community, has a ton of plugins, and it's very extensible. And I think they work a lot with AWS as well to integrate with new features that are coming out. So we work with Jeremy Daly over there. And then we also saw a lot of usage of just these other tools for managing your serverless apps. And so it's almost difficult to pinpoint exactly what these do, because they're both the infrastructure as code tool that you use to describe your application, but also the command line tool that you use to test or deploy things as well. And you know, would love to hear sort of how you see people use this. And I remember like one of the compelling reasons to use SAM in the past was that you could do sort of offline testing with like Lambda layers, and you could test against like local versions of DynamoDB. And so yeah, curious for like what are the usage patterns you see, especially between these different AWS offerings? How do I make sense of those?
Yeah. I mean, for me, the biggest thing I always try to get our builder, you know, developer customers to do is to use a tool. So if this was representational of everyone launching Lambda, you know, functions themselves, and I could say, oh yes, this means that, you know, 80% of all Lambda functions come from one of these tools even. That'd be incredible. Like that would be really awesome to see. You know, I think what it also though shows is that different strokes for different folks, as it were. So, you know, across these different tools and who might be using them, there's a lot of varied needs, a lot of varied backgrounds. You know, I would say that the people that are writing in, you know, vanilla CloudFormation, they probably are more likely the more traditional ops user. There's someone who's maybe not doing as much focused serverless work, or willing or looking to develop in the languages that CDK uses. And then across things like CDK and SAM, both of which are tools that are made here by us here at AWS. Again, I think it just represents what customers are looking to do in terms of how they think about tooling. So CDK allows you to manage and deploy your resources using more traditional development practices. Whereas SAM is actually just an extension on top of CloudFormation and is really just another infrastructure as code tool. And so, you know, how they're used differently and by who really kind of varies depending on the person, their background, their experience, and how they're looking to build apps. All of these are, you know, active projects that we're growing and doing a lot with. And actually just about 2, or actually longer now, back at the end of April, we announced integration between AWS SAM and CDK, such that you can use what's called the SAM CLI command line tool to do local test of CDK defined functions. And so this gives you one of the, again, like you mentioned, core benefits of AWS SAM, which is this local emulation of the Lambda environment, of an API gateway, the ability to test out your function in a local developer workflow. And so, you know, we'll continue to build these things both closer together in their own paths and try to weave together the story. But I think the key thing that I always want customers to come away with is that, you know, you really shouldn't be doing all this stuff by hand. You really should leverage a purpose-built tool. You know, in regards to serverless framework, they're the OG. They've been around here with us since, you know, almost day one. Austin and folks there, and then the open source community around it. A lot of really interesting, exciting stuff coming from them, you know, over the last couple of years, and from Jeremy's tweets, hopefully coming soon as well.
Yeah, and what you said a couple of times was you always recommend people at least use some tool. And I think what we found really surprising in this data was that a lot of these CloudFormation stacks. So you talk about CloudFormation as an infrastructure as code tool, you know, similar to Terraform if you're used to that. you can take it a step further and describe multiple resources with a CloudFormation stack. So you could have a stack that's your API gateway and your Lambda function and your database. They all get deployed together. If something goes wrong, you don't have a partial deployment, everything rolls back and everything is kind of an atomic unit. And so what we see is like a lot of these tools are built on top of this like idea of stacks that's super powerful, but we were really surprised to see like typically only one Lambda function is being deployed at a time in these stacks. And you know, in our methodology, we excluded some common infrastructure tools that developers use to like send their logs to Datadog to make sure we didn't have skewed data here. And we still saw this shine through. And so I'm curious, like, does this seem to you like maybe a sign of like developers still kind of understanding how to best incorporate these tools into their workflows?
Yeah, I think it could show a couple things. One is definitely with Lambda, you have this concept of, this event-driven architecture, which often means that it marries itself really well to a one-to-one mapping between an invocation source and a Lambda function. And so you see a lot of these like smaller workloads that will exist inside of an organization, processing data off of a Kinesis stream, processing data off of an SQS queue, processing data off of, say, S3. And so those are places where those will typically end up as, independent microservices, if you will, inside of an architecture. I think a lot of these are also those kind of IT glue workloads that we talk about. So, plugging things in to respond to, sensor events or metric or log-based events inside of an architecture. That's still a lot of places where Lambda gets used. Like Lambda is the best Swiss Army knife for an operations, DevOps, SRE person, I think. At the further end of the spectrum here, where you have that 10 plus number, those are probably the workloads that are more complex APIs. So those are, API gateway backed by many different Lambda functions, each with a very unique purpose. Now, one thing that we do see is that some of the frameworks that people use inside of Lambda will create what's called a lambda-lith, where you have a single Lambda function that actually does business logic routing inside of it. And so there's a couple different tools out there that will basically shim a middleware into your Lambda function, such that one Lambda function represents, again, it could be that 10 plus use case of different API backends. However, it's in a single function. And so we battle over if that's an anti-pattern or not, but I do bet that in this first column here, this represents some percentage of what's being shown.
Mm-hmm. And we had a really interesting question come in about this of, do you see people commonly using like specific tools like SAM or CDK for one job? So SAM for provisioning, API gateways, CloudFormation for managing something else, or CDK for managing databases or like IAM roles?
So I think what we typically would see is a CloudFormation plus one. So you would see CloudFormation for core infrastructure resources or things like RDS databases and stuff like that, and then you would see a SAM or a CDK. That said, we see a lot of customers with CDK that build more than serverless applications, whereas SAM is pretty much just for serverless applications. And so, we still see a whole lot of CloudFormation usage at the end of the day for all those other things that you end up needing to manage.
Yeah, that makes a lot of sense. It seems like a compelling reason why people would use CDK.
Yeah.
And then our last bit of research to share for the day, this one is in two parts, but following up on, last year we looked at which runtimes, which programming language is the most popular to run in Lambda. And this year, again, we saw Python being the most popular, with Node.js being the second, and then a tail of Java, Go, .NET, Ruby, and custom runtimes. Mm-hmm. Is this surprising?
So I would say that we see Python and Node a little bit more even in the data that we have internally. I won't get into the exact percentages here, but there isn't the same kind of gap that you see between the first two here. I think for the rest of them, though, it fits decently well. Java remains really popular in enterprises, remains really popular in both data processing and ML workflows. .NET as well. We see a lot of interest in serverless with .NET, especially as the .NET core languages continue to evolve and get better and better and better. I would say, Go is still a newer kid on the block, as it were, in some organizations, and so it's an interesting one that continues to show up in certain types of workloads, certain types of needs, and then you've got things like Ruby, which Ruby is still very much kicking out there. There's a very active community around Ruby in the serverless space. Again, not as big as Python and Node, which are our two oldest languages, but still something that's super active for sure.
Yeah, and then I remember you mentioning, or we had a conversation before around like custom runtimes like PHP, Swift.
Yeah.
Where do you see those falling on here? It seems like those probably have loyal followings.
They do. They definitely do. It's really interesting. Ben Smith on my team wrote a series of blog posts last year about getting PHP running inside of Lambda, and worked with the community around some of the open source projects that are there. And it was just like eaten up by that community. They were so excited to see that being talked about that way. And so the custom runtime feature definitely unlocks a lot of different languages. And we have customers doing C++. We have customers looking at things like Rust and Erlang, and it gives them the ability to run those languages that they're comfortable with. So it's, is it the edge of the spectrum? Yes. But is it still a first-class citizen insofar as you can get kind of the same benefits from all the rest of the parts of the stack? Absolutely. And so again, while Python and Node might represent the overwhelming majority of what customers are doing, the experience is still pretty much the same with all the rest.
Yeah, it's very interesting to see, and yeah, curious what we're going to see more of. Swift on the back end has been a thing people have been talking about for years. So
yes, yeah. So Swift, there was a runtime that was announced back at the end of last year for Swift, and it's really interesting. Again, any place where you could run, where you could develop in the same language across multiple parts of your stack. The concept of a full stack engineer just becomes that much more powerful when you're not context switching between languages. And so that's a newer one that there seems to be a very interesting community bubbling up around as well.
Yeah, thank you. And so that's a majority of the research we found. I encourage you to go look at the report. This is a link to it on here. And we got a question earlier about thoughts on Lambda extensions, what it means to invoke a function that can return a response while you can have some programs, some agents and extensions still running in the background. And we just worked with AWS to release our extension. So for us, it means that our customers can simplify the way that they send telemetry data, their metrics, logs, and traces. They can do it in a way that is asynchronous from their function executing. It also means that you can send logs and data directly to a provider like us. And it's just overall like a cost-effective, very easy way to set up to get insights out of many functions at once. And so, curious from your angle, where we provide monitoring, but what are the other use cases you're seeing, especially in people building their own extensions?
Yeah. So for folks who aren't familiar with this, last October we announced a capability called AWS Lambda Extensions. At that point in preview, just yesterday it went generally available. After a number of months of working with customers and partners like Datadog on improving the performance of it, enhancing some of the capabilities. A couple of months after the initial launch, we added enhanced capabilities around capturing logs and sending them to different destinations. And so what extensions is, again, trying to keep the naming straightforward here, it allows you to extend the Lambda environment such that you can have other technologies, other agents, for example, run alongside of your Lambda function code. And that can happen either out of band, essentially almost like a sidecar process, if you will, or it can happen in flight with the event. And so key use cases around obviously observability, so monitoring, logging, metrics collection from different points around the function, aspects around security, so being able to look at the event, to look at what the function is doing and understand if there's anything anomalous there. Things like configuration management, secrets management. So for example, things like HashiCorp Vault, having the ability to pull data out of that or AWS's app config service. So there's a bunch of different things that exist inside of there. And actually, I would love for next year when we all do this again to see what percentage of customers have enabled an extension on their function. I think it's going to end up becoming a really key aspect of building with serverless technologies and Lambda in particular in the future, just because it allows our mutual customers to get so much more visibility and understanding of what's happening inside of their Lambda functions, which is maybe one of the things that, has been, I'll say a blocker for some customers that have certain tools that they really love that wanted to have better integration with Lambda. So bunch of stuff like that. Again, there's a whole range of different companies with different capabilities that have built extensions, and you can also build your own. And so I talked earlier this week with a customer who wanted to build an extension to maybe purge sensitive data out of the function environment. So after a function runs, hey, we want to go through and clear out the temp space and maybe make sure that we clear out certain environment like in-memory storage. And that's something we don't have built today, but that a customer very well could build. We have customers that are building extensions that tie in with event tracking infrastructure on their side, for example. So there's a number of different capabilities that are out there. And again, it exposes a whole life cycle around a Lambda function running and existing that I think it's still pretty early days for us to see what comes out of that.
Yeah, we're also super excited to see how people use this. It definitely is early days, and we're glad to have our extension out there and generally available as well. I think there's a lot that developers can get out of moving over to this, and especially for people moving to serverless for the first time. Like I think sometimes these serverless applications can get very complex. You have many simple pieces, but they can pretty quickly get very large. And so anything you can do to simplify, I think the setup process, the day one visibility that you're going to get, I think will be a win for a lot of people. So yeah, looking forward to next year, hopefully looking at how we see extensions being used.
Absolutely.
Yeah. Well, I know we're a little bit over time. Really appreciate everyone's questions. Chris, do you have anything else you wanted to talk about, or do you have time for another question? Should we wrap up?
I just saw there was a question around warm and cold starts. Insofar as Lambda at Edge, you still could potentially see a cold start happen. With CloudFront functions, it works a little bit differently. So I don't believe that you would see the same type of cold start action or impact. The same person asked a question around scale of step functions. So step functions can scale massively. I haven't really seen customers that have run into a concurrency challenge with step functions, but always good if you think that you're running a really, really massive workload to talk to us so we can help clarify that for you. Awesome. But that's it. No, this is great data. We're always excited to see what organizations like Datadog could pull forward from the types of things that you observe. And again, we're excited to see the serverless community grow and to keep evolving and doing more and more. Yeah, really appreciate you being here today and shedding some light on this data that we collected. Very excited to work with you on future reports, future Lambda functions. Lambda features. Yeah, we can work on some Lambda functions too. So we can do some co-programming type stuff. Yeah, we can write some code. Yeah. Awesome. Well, thanks for having me, and again, thanks for providing this data out there. Yeah, thank you. Have a good one. Thanks everyone for attending. Yeah, thank you everyone. Okay. Cheers.